Hello, and once again, welcome to the 13th day of our 15-day physical science program for class 10. And it's really a stupendous task for those of you who are continuing with the same zeal, Z-E-A-L, and interest and passion till the end. It's really commendable. And I find a large number of those who are joining in Zoom and also watching live, they are out of patience and they perhaps will watch little later, not direct. But anyway, we are having the same passion as we had initiated 13 days before, 12 days before. And Om Prakash, welcome. Rudra, welcome. Let me share my screen without further delay. Anubhav, you are late by 1 minute. No, we had left a little bit in this. Let me revise that a current carrying conductor will produce a magnetic field, and you can find the lines, field lines for this current carrying conductor by using the Maxwell's right hand thumb rule. If the thumb will represent the direction of the current, then all other fingers curled around will give you the direction of the magnetic field. And that magnetic field will interact with the magnetic field of this permanent magnet present in the magnetic compass. And because of the interaction, since it is moving to this one, moving to the west, on the east side, there will be more field. The field density will be more because of the interaction of the two fields. When this is below this conductor, then we will see how two conductors kept side by side interact with each other by the cancellation of magnetic fields, by the reinforcement of magnetic fields. So since it is moving to the west, the other side is rich in magnetic field, is richer, and this side will be purer. So always there is a motion of any mechanical object, that too a very tiny object having no friction can tilt very easily on a pivot. So it goes from a higher field region to a lower field region, deflected to the west. And if you keep it to the keep it above this wire, then this North Pole will be deflected to the east. The opposite thing will happen. due to the cancellation and reinforcement of fields between the two magnetic fields, magnetic field created by the moving current, the current and the magnetic field of this permanent magnet. Opposite thing will happen if the current will pass from north to south. The north pole will be deflected to the east if it is kept below, and if it is kept above, it will be deflected to the west. And now you can appreciate why such a thing happens, because this is a magnet, this is a magnet. Two magnets are side by side, they interact. And I will show you after some time how the field lines, they interfere, they sometimes they cancel to make the resultant field, magnetic field, rarer, means weaker, and the other side it will be stronger due to the reinforcement. That means having the same direction, they will be stronger. So there will be a mechanical motion from a higher field region to the lower field region. And that mechanical motion has been quantified or had been qualitatively explained by FLR. FLR means Fleming left-hand rule that we have studied. So in this slide, I don't think we have anything to do. Just I remind you that the field that is produced at any point at a distance d of the current carrying conductor will be directly proportional to the current passing through and inversely proportional to the separation, the distance. And the proportionality constant is the permeability upon 2 pi. Permeability is a measure of resistance that is offered by the medium to form the magnetic field. I mean, they are inversely related. More is the permeability, less is the resistance to form the magnetic field. That means magnetic field can be formed easily. The magnetization of the medium can be made very easily. And the Tesla, the definition of Tesla is very interesting, from which you get the unit of Tesla. 1 Tesla is the field intensity which generates 1 Newton force of when 1 ampere current passes through a 1 meter conductor. Then at any point P, if it generates 1 Newton force, then the field at that point is 1 Tesla. That is why Tesla unit is Newton. 1 Tesla is equal to 1 Newton per ampere per meter. And the unit of permeability, this is mu. I have to correct it. This is symbol. Is Newton per ampere square. Per ampere square. Or Henry per meter. I have not told you anything about Henry because it is a unit of inductance. I'm not talking about inductance now. Just Henry per meter is also another unit for permeability. Now, we had done also how to find out the direction of the magnetic field at the center in exactly the central axis by following the same FLR. But this time, the other fingers will show the direction of the current and the thumb will show the direction of the magnetic field at the middle and the axis. But if you go nearer, then it will be curved. And that, to understand that, you come almost to the end of the coil, that is a small portion you take, treat it as a straight carrying conductor, you will find circular lines of force, or I mean magnetic field lines. These things you know because I was in a hurry yesterday. Today I'm not in a hurry. I will be clarifying every doubt in a very, very cool and systematic manner. So let me switch off my mobile. That is really a nuisance while we discuss and study. And we know all the difference between a coil and a solenoid. All solenoids are coils, but not all coils are solenoids. When the turns are placed in a helical manner so that the length of this coil is much greater than the diameter, the L/D ratio is high, and that too, the turns take a helical shape, not circular. Helical means it will be winding in an inclined manner, so it will be moving forward. So that is the helical manner. So like a spring manner, just like a spring you have seen, that becomes a solenoid. Solenoids are used to prepare powerful or less power, whatever, electromagnets mostly. This is the length upon diameter. L/D ratio is large, but coil, the L/D ratio is very, very less. This is the length of the coil, this one. And the diameter is very large. So that is used in armatures and other devices, but this is for getting electromagnets. And we know that inside the solenoid, if the current is passed, then inside the solenoid, if it is a long solenoid, then it produces a uniform magnetic field, and that magnetic field is independent of the distance from the midpoint or the axis of the solenoid, and also independent of the cross-sectional area. And the field at any point and every point, the uniform field is, at this time there is no 2 pi in the denominator, and here I is the common thing that was found in a straight current carrying conductor. I is common, but there the distance from the conductor to that point, but here the number of turns N and L is the length of the coil. It's not D, it's the length of the coil. That means how long it is being wound in a helical manner, the length of the coil. And there is no need to revise how you will find which one is the North Pole and which one is the South Pole in a solenoid in which a current is going on, passing on, either by holding it, applying the Maxwell thumb rule, or by going to a terminal, this terminal or that terminal, any one terminal, if you find it is coming anticlockwise, the current is flowing anticlockwise, it is north, and hence the opposite pole will be south, where the current from that end will be flowing clockwise. We have discussed that. There is no, and also discussed the relative permeability is more than one, and that is given K in another equation instead of mu r. This is given K in most of the texts. This is the permeability of the air or empty space, which is fixed, and other medium also fixed, but you get a table where you get the relative permeability that is multiplied with mu naught to give you the mu. So we know many substances can be converted to permanent magnets, particularly the hard magnetic materials. But the soft materials are usually taken to get temporary electromagnets, not permanent. And we also have seen, this is a very small example, it's a very simple example of a solenoid wound around a nail, and you can test that it has become a permanent, it has become a bar magnet type, because a solenoid operating on a current acts like a bar magnet. The outside magnetic field lines can be drawn just like the bar magnet from North Pole to South Pole, North Pole to South Pole. And inside it will be uniform. That uniform, of course, goes from south to north, no doubt, but that uniform magnetic field is determined from that equation we learned, B is equal to mu N by L into I. And this is the induced Prerita. This is a electromagnet. And as long as it is a magnet, it can attract ferromagnetic substances. And it can continue this. If you put another clip below the first clip, it will be also clinging onto that because this has been already induced into a temporary magnet. The poles are polarized. I mean, it is a polarized, supposing this is the south pole of this electromagnet working on a solenoid, for example, this is south pole, then the paper clip, this will be north pole. This is the south pole, the first paper clip. And if we just cling another paper clip to the first paper clip, then if this is north, this is south, then the other one will be north and this will be south. So the domains will be induced to align in a particular direction in a manner that we shall study today the principle of induction, that is Faraday's laws of induction, that we'll study today. Okay, then what we were doing, I can just remind you that either you can use FLR, but often students are told by their teachers around the world not to use the left hand, but to use the right hand, both for getting the force direction, the motion direction, when a current carrying conductor or a moving charge is passing through a magnetic field, then the force or the motion is perpendicular to the plane carrying the field and the current. They may not be perpendicular. If they are perpendicular, it is well and good. If they are not also, they will lie in one plane and the force applied or exerted on the conductor will be perpendicular to that plane. And you know how to, that thing we will study today. If the angle is not 90 degree, then what will happen to the magnitude of the force? And how to know the direction of the force? This is the primitive FLR. What is FLR? FLR is Fleming's left-hand rule, or the right-hand third rule that we can use elegantly without using the left hand, which is not a good hand for Indians. I mean, most of the people, they are righties, not lefties. And so, but there are some people who are lefties. They are nature. These are nature-made lefties, not made lefties. They are born lefties, I guess. But some people think that had you trained your son or daughter to use right hand while he was a child, an infant, a baby, then perhaps he would not have been a lefty. But I feel, I'm inclined to differ, not to agree with this concept. Anyway, it is debatable. And today we shall take up the third way how to find the direction of the force exerted on the conductor using the vector concept. We have done all this. And if it is a moving charge, and that too a positive charge, if it is a negative charge, flow of electron, then you take the opposite direction as the flow of positive charge, then apply the FLR or the right-hand third rule. Can anyone tell me, if you use the right-hand third rule or the right-hand pushing rule, then which fingers will be showing the direction of the field and which finger will be showing the direction of the current? Yes, anyone? You can just tell me. Because today is almost 2 days before the last, and 4 guys are watching me live. Doesn't matter if Rudra is alone, Mr. Padhi is alone, then also I will have the same passion and zeal to have this recorded video, which is in a live telecast mode. Yes, Rudra, you raised your hand first. Tell me. ସେତେବେଳେ ଡାହାଣ ହାତର କୋଉ
କରେଣ୍ଟ ର ଡାଇରେକ୍ସନ ଦେଖେଇବ ଆଉ ଅଦର ଫିଙ୍ଗର୍ସ ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ ଡାଇରେକ୍ସନ ଦେଖେଇବ
କଣ କଣ
सर थंब टा करंट रा डायरेक्शन देखियो आउ अदर फिंगर्स टा मैग्नेटिक फील्ड रा डायरेक्शन
यस बस एठी कोन करिवो ना द palm is kept straight, not like this, straight, as well as the finger, the thumb, the thumb must be perpendicular to the other fingers and they will lie in one plane. And the thumb will show the direction of the current, but in FLR it was showing the direction of the motion, the force exerted. M, I told you, motion, but here it is current. Then these other fingers which are in the same plane but perpendicular to the thumb, it will show the direction of in this one, the fingertip will show the direction of the field from north to south, like this. And then if you push in front of your palm, as we funnily call, give a thappad in front of you, say anybody is sitting on you in front of your palm, then if you push your palm and slap anyone sitting or standing in front of your palm, then that direction where you push your hand forward, to move the palm forward, not backward, that is the direction of the force. So you can, now we study in a different way, and that was left. This one, yeah, I think I have told you this. Let me revise. The reason why there is a force and in which direction it will go, supposing cross means into. Supposing a conductor carrying current is going into the phase and the direction of the magnetic field is here, north to south. Then what will happen? The current will generate its own magnetic field, which can be known from the Maxwell right-hand thumb rule. If thumb will represent the direction of the current, then other fingers curled will give you the direction of the magnetic field. So if you do so, if you always make your right hand always active, even for FLR, we don't use FL, we use FRR in a different way. The only difference is the thumb will be current and other fingers will be the field, and pushing direction will be the motion. Now see, this is going into this is the Maxwell thumb rule. Then the curling fingers will give you the direction, so that the magnetic field and the current's magnetic field, they are on the same direction above the current carrying conductor and opposite direction below the current carrying conductor. So they add up, reinforce above, and they cancel out below. So the field becomes the field becomes weaker below, stronger above. So there is always a force acting on that mechanical device carrying current. In this case, it is a straight carrying conductor from higher field strength to lower field strength. So it will be pushed downwards. This is the logic, scientific explanation of the FLR, or the direction of the force which the current carrying conductor experiences by the presence of an external magnetic field. Now, I have asked which rule you liked, Fleming's left hand rule or physics teacher's Thappad rule. If latter, please don't slap anyone. This is for fun. Don't really slap. And if a conductor is carrying current above the plane, out of the plane, then if you apply the Maxwell thumb rule, it's coming to your nose, then this one. Then it is cancelling out above the conductor and reinforcing, strengthening below the conductor. So the conductor will be pushed upwards. Same result, consequence you will get if you apply FLR or the right hand Thappad rule or pushing rule. Now let us take the third way, because you guys were interested in the advanced, super advanced scan. And sometimes I have been making this program as super advanced. Sometimes, not every time, but there we'll be having every time super. Now, as I told you, I was in a hurry yesterday, that the force can also be found out as the cross product or vector product between the IL vector. I is not a vector, but length is a vector. The length of the conductor, that is a vector, and the direction of the length vector is the direction of the current. Direction of the length vector is the direction of the current. So IL cross B, that gives you the force exerted onto the current carrying conductor, both in magnitude and direction. The magnitude is, if there are two vectors multiplied in a vectorial manner or cross manner, then the magnitude is the A into B sine theta. In this case, IL into B into sine theta. So it has been slightly rearranged to to hear very funny Bill sine theta, BIL sine theta, or we can call it ILB sine theta, same thing, BIL sine theta, right? And how to know the direction? Because I told you that the vector product of two vectors is itself a vector quantity. So the direction of the product can be known again by the right hand rule. There is another right hand rule to know the direction of the product vector. When you move other fingers, just like your right hand Thappad rule, in the same way you give, but this time don't push, you have to curl. If you have to move, not curl, you have to move. If the other fingers moves from the vector A to vector B, then the thumb, which is perpendicular to this, that will give you the direction of the product vector. And if you make the other way around, B cross A, so you have to go B first and then come to A. So B cross A will have the same magnitude Bill sine theta, but the direction is opposite, that they are not same. But in case of dot product, so whether you multiply A dot B or B dot A, because it's the product is a scalar quantity, so it has no difference. They are commutative. B dot A is equal to A dot B. But here, A cross B is not equal to B cross A. The directions are opposite, although the magnitudes are same. Now, let me show you here. If this is not the way I explain. I explain in this way. If you move your other fingers from A to B, because you have written A first, B second, then the thumb will represent the direction of the product vector. So B cross A is equal to minus A cross B, is not equal to A cross B or equal to minus A cross B. You can put a bracket sign here. Right. So this you already know. Now let us apply the third rule here. We have applied two rules. The FLR, the right hand Thappad, for example, T is Thappad. Thappad is an Indian word. Pushing rule. RHP. RHP. This is FLR, Fleming left hand rule, and this is RHP, right hand pushing rule, RHP. So if you now apply the vector product rule, now supposing the length vector is having the direction equal to the current direction. So do like this. Do like this. So you go from the length vector. First is length vector. You can't change. That is the rule. First the length vector, then the B vector. So since like this, this current is in this direction, it is shown by I mean the other fingers, because that is a vector. Then we will go to the direction of the A vector. I think I'll be having a spondylitis today. So we are the current vector, I mean the length vector is upwards. So this and this word, and you will go this. So the thumb is to the left. So the force will be explained now. Vector direction current length vector direction move to the field vector. Empty. Field vector north to south go jaichi. Empty. Empty no. एमती करिवे केते बेले जदी जाउथांता इनटू द प्लेन करंट डायरेक्शन ता ऑपोजिट हे जीवो ताहले मु एमती करिवे आगो द लेंथ वेक्टर then I will come to the magnet is not changed, magnet is remaining the same, so एमती गले it will push to the right. Now मते केते कष्ट करी करथिली एमिति ए वेक्टर वर्तमान ए बाहर को आछि करंट. So current is not a vector but length vector. The direction is that of the current. वर्तमान जीबी को वेक्टर को ना बी वेक्टर को, not to south, एमिति ऊपर को अछि एमिति गले महतटा thumb is giving the direction of the product vector, that is the force vector, right? So you can apply some charts, thumb direction of current. Oh, Purbata, yes. I hope you understood. Raise your hands who have understood how elegantly you can also. I don't recommend to use this vector method to know, because it will be really very strenuous sometimes, because you will be put the other fingers in direction of the current direction, length vector, and then move it towards the direction of the B vector and see where your thumb points. That is the direction of the force. So Ms. Shraddha Suman, Mr. Padi, Anubhav, Arja, Pragya बुझिलनि कि प्रीतम तो मझे मझे आसुछ, very good. Pritam, so anyone who is watching from a distance, not here with me, 5 of them are watching. Have you understood? Let me write down. Have you understood the vector method? Okay, now we shall be moving to another, I can show you a very interesting experiment. The same thing. एठी गोटे तार लगेछि केमती से सेपट को जीवो एपट को जीवो करंट डायरेक्शन चेंज कर देले एपट को जीवो आ गोटे डायरेक्शन रे भीतर को जीवो ए भीतर को गला आर पटो चेंज कर देले बाहर को जीवो बस. And I have also told you, not told you, that if it is a moving charge, then instead of the length vector, it will be the velocity vector multiplied by q. Q is a constant here. There, I is a constant, but here q is a constant. And in place of the length vector, you get v. This is q v b sine theta. Same thing. It's a cross product of q v cross b, and you go to the direction of from the direction of the velocity in which the charge is moving that direction, then move your other fingers to the direction of B, then the thumb will point out the direction of the force which the charge experience. This time you always take a positive charge. If you take a negative charge, then in whichever direction it is really moving, but draw the vector in the opposite direction. That is the direction of the motion of the positive charge. Right? Always the Fleming rules are based on the movement of positive charge. If at all you are given motion of an electron in this direction, then you immediately make the direction opposite and then apply whichever of the three rules you know, starting from the origin FLR, then RHP, third rule, or RHP, right hand pushing rule, or the vector rule, to get the same thing. I have one problem which I have solved it. You can just have a look. And here, that's interesting. Deta jodi eta ye hi jaichi. Yaro eita taro seita. So that's one dekho. Jodi dita conductor, straight carrying conductor parallel rahile এবং দুইটা জায়গার কারেন্টর ডাইরেকশন সেম রহিলা, দেন তাଙ୍କ ভিতরে অ্যাট্রাকশন হবে, ସେମାନେ পাখକୁ পড়েবে, they will bend and attracted towards each other. যদি অপোজিট ডাইরেকশন রহিলা, তো there will be repulsion. কাହିଁକି ତମେ ନିଜେ କରିପାରିବ ଯେତେବେଳେ ସେମ ଡାଇରେକ୍ସନ ରେ ରহিଲା, এইটা ଏମିତି ଯାଉଛି and এইটা ଏମିତି ଯାଉଛି. So the two fields oppose each other in between the conductors, so that outside रे सेमानक reinforcement होनी, किंतु inside रे सेमाने कटाकटी होचंती. So relatively outside, support outside ro field is more intense than in between, because you can just see empty जाउची भीतर को, एटा empty जाउची. So empty asal को empty asal they कटाकटी each other. So ultimately the field is weakened inside or in between. So higher field to lower field ku gote push hobo, so the result is an attraction. But on the other hand, so the opposite direction of the bomb, dekho eta upar ku jauchi emiti, eta tolu jauchi emiti, so dita jaka missi jibe, phol re kon hobo, the field inside eta ar, the field inside will be strengthened compared to this field outside. The field inside will be strengthened compared to outside. Gote jodi toluku gote jodi upar ku, they are opposite, the cross dot. So theta ka same direction re, so the inside will be weakened, outside relatively stronger, so attraction. Eti opposite hobo, in between strengthened, outside relatively weaker, so it will be repulsion of a higher field to lower field ku jibo, so repulsion. So that you can apply the same logic to the motion of the compass needle when put below, put above, and the direction of the current from south to north or north to south. You can apply the two right hands Maxwell rule and see in which part it is strengthening and which part it is being weakened, so that if North Pole goes to the west, then the east side is strengthened, the west side is weakened, so it is moving from east to west. The motion is towards the west, for the North Pole, and for the South Pole, it is the opposite, because it is a pivot standing on a particular point, that is a pin, and therefore, if North Pole goes to the west, the South Pole has to come to the east. So you can yourself verify and ask. Now our 10 minutes more, we can go to apply to the concept of motor, because usually teachers, they like to teach both the FLR and FRR, I mean EMI and the force exerted onto a current carrying conductor in a magnetic field. They teach together, and then they go for a motor and generator. These are the devices, but I do not do that. My way of handling things is to utilize what you have learned. It is the creation of a new magnetic field by the current, which interacts with a permanent magnetic field. And as a result, there is a mechanical motion. So this concept is nothing to do with the opposite concept, where there will be no current in the beginning, but magnetic field will create a current. Prerito karibo. It will be inducing a current, inducing a EMF, and hence an induced current. Agru kichi current nothila, battery nahi, kichi nahi, gote khali coil achi. Tume magnetic field taku change as long as it is being changed with time, then you will find there is a motion. I mean, there is a flow of charge. I'm sorry, there is a flow of charge. A current will be flowing, so it will be maximum, then minimum it will be flowing. But the moment there is no change of flux associated with that coil, there is no current at all. That will be doing EMI, easy monthly installments. That concept is opposite of this concept. So let us apply the FLR or RHP or the vector concept that we have studied in the DC motor. AC motor is really intriguing. Until we study EMI, we cannot tell about AC motor. You must be wondering that the fan that you are having above you, or the fan that is in your AC, in your car, carburetor, the fan, there are so many devices where motor is working. There is a shaft, it is rotating, and that rotation is due to FLR, RHP. So chalichi continuously se motion chalichi, se shaft tame jaha lagele se bulla, pankha lagele kati lagele kati bulla, pancha kati lagele pancha kati bulla. Seta jodi gote rubber tire re lagebo, se tire ku buleila, rolling friction age nela. So what I was saying is AC motor ame jo use korche, jette use korche ame ghare fan, oda so AC motor. Alternating current teme bhabubo, alternating current ko emiti hawa katha kahinki sidha emiti boluchi. So that concept, tar origin hochi EMI. Itire dita field, gote induced field, siye produce koruchi gote constant motion. How gote, there are two coils. But in DC motor, which is taught to school level students and up to class 10, maybe in class 12, when you study electromagnetism, your teacher will teach you details about the AC motor that we really use in our household places. Now, first, let us understand how a continuous rotation, clockwise or anti-clockwise, is possible by using a DC current. A DC current provides a continuous and constant current for a long time. You can use a battery, 9-volt battery, 12-volt battery, which is an electrochemical cell. I mean, in a cell connected in series, that battery will work as a DC source. If you do not change the polarity, keep the circuit fixed, then it will be giving constant current in a fixed direction. Of course, we'll see later, maybe in the next program, that we can convert the AC that we are really getting in the generator. When we study EMI, we will know that our real source in a hydroelectric power plant or a thermal power plant or a nuclear power plant is not DC, it is AC. We are getting AC, but the devices which we are using, they need the DC. Therefore, we use an eliminator. When we charge a mobile phone, we have an eliminator that acts to convert the AC into DC. So that is done through some rectifiers, diodes, triodes. So they use there to convert the AC into DC, and to reduce, there is also a transforming capacity, transformer additional advantage, that we need 9 volt, but the town supply is 220 volt, but our device, mobile, doesn't need that much. It's a very low voltage, so it not only steps down the voltage but also makes AC into DC. That is the work of an eliminator. So that is used for charging every electronic device which needs DC current. But about the AC fan that you are using above our heads, that is a typical concept, and that is not the one that we are studying now. Now see, এইটা গোটে মোটর, এই যে বাহারছে এটা একটা সাফট, তা ভিতরটা কাটিকি দেখা যাଉଛି, ଏଠି ଗୋଟେ আর্মেচর বুলুଛି, বুলিব, সে করেন্ট পাস কলে সে অটোমেটিক বুলিব, এন্ড তা দুইপট সাইড রে ম্যাগনেটিক ফিল্ড ଅଛି। সো ম্যাগনেট গোটে ଅଛି, পরমানেন্ট ম্যাগনেট ଅଛି, এটা গোটে কয়েল, এটা গোটে ইলেক্ট্রোম্যাগনেট। অফ কোর্স ইট ইজ এ ফিক্সড ইলেক্ট্রোম্যাগনেট। বেলে বেলে পরমানেন্ট ম্যাগনেট ইউজ हुए, বেলে বেলে electromagnet use हुए। So गोटे current use हुए to produce electromagnet। आउ एटा जो अछि आर्मेचर, सेते गोटे कॉइल अछि भितरे, से कॉइल टा मध्य भितरे मध्य इलेक्ट्रिक करंट पास करा जाए, डबल करंट गोटे। बट यूजुअली परमानेंट मैग्नेट यूज हुए। आई एम शोइंग यू this is a permanent magnet at a north pole, at a south pole is a permanent magnet। एटा भितरे जोटा अछि coil owned over a shaft। Coil is not a solenoid, is a coil with having some turns closely spaced, length to diameter ratio is not much, so it's a coil, and that is fixed onto a long cylindrical narrow iron shaft। ये shaft रे एटी जहा लगेइबो, shaft माने coil जते बेले घुरिबो, से shaft को नै करी घुरिबो, एवं shaft रे जदी 3 काती लगेइबो से फैन हे जिवो, 4 काती भी फैन हे जिवो, रबर जदी चक लगेइबो से चालिबो, मोटर भी चालुथिबो, ये चालले मोटर भी ता सहित चालला, गाड़ी तम बसी की चाललो। And the interesting part is the split ring commutator। विखंडित बलय मझरे फांका अछि, सेपटे भी तळे फांका अछि, ये गोटे स्प्लिट रिंग, ये गोटे स्प्लिट रिंग मिसी जाइनी। हमें पढ़िबा दीटा रिंग यूज हुए एसी, जो हमें प्रथम पढ़िबा जे कांसेप्ट ऑफ जो स्लिप रिंग, सेटा हमें पढ़िबा जनरेटर रे, एसी जनरेटर रे पढ़िबा, एंड सेम कांसेप्ट को हमें यूज करिबा एसी मोटर रे, जोटा यूजुअली तम स्कूल रे कहा जाए नहीं, व्हाटएवर इज टोल्ड इज डीसी मोटर। सो डीसी मोटर कांस्टेंट सप्लाई करूची, एंड देखो ए दीटा एक्सटर्नल सर्किट रो लोक, एटा गोटे ग्राफाइट ब्रश, जोटा घसी हबो कोठी ना स्प्लिट रिंग कम्यूटेटर को घसी हबो, जस्ट फॉर ए फ्रैक्शन ऑफ ए मोमेंट एटा स्लिप कर जीवो। जो जते बेले बुलिकरी एमती बुलुथिबो, तो मु कहिबि केमती बुलला, तो एंटी क्लॉकवाइज बुलुची, गोटे समय रे 90 डिग्री टर्न होला को ए जगह को पळे आसीबो, सो दैट द प्रोसेस विल नॉट बी इन कांटेक्ट विथ एनी वन ऑफ द कम्यूटेटर्स। स्प्लिट रिंग कम्यूटेटर का संगे सेही अल्प समय पई, गोटे मोमेंट पई, देयर विल बी नो current passing through the coil. But inertia is so powerful. The inertia of motion is so high at that time. Se fatkini inertia taku ghunchei dela mane tikke ghunchei dela mane se puni connection hegala aro split ring re. So current direction badali gala inside the coil, but outside the coil external circuitry current direction same achi. And interestingly, the rotation direction will remain the same, either anti-clockwise or clockwise, going on and on and on, if you do not change the direction of the current, because you are using a DC source. Now see what will happen. Let us apply FLR or a right hand pushing rule or Thappad rule or the vector rule. Vector rule both cost. So आमे धर गोटे समय रे पैरेलल अछि एक्चुअली स्टडी करा जाए जो आमे देखिबा ग्राफ करा जाए बा एनालिसिस करा जाए वर्टिकल पोजीशन किंतु मु तुमको कहबी पैरेलल पोजीशन मजा जिंस होची ये गुडा को वर्तमान तो टाइम हे गलानी तो आकु आमे पुनी डिस्कशन करिबा ए जो नॉर्थ पोल साउथ पोल को एमती कर्व करी करी कटा ही था so that जो मोमेंट रे तुम देखिबो कॉइल रे बुरुची सी पैरेलल थिबो कारण एटा फ्लैट नुए एटा कर्व्ड सरफेस that every time the coil is rotating it will be parallel to the magnetic field and the force exerted on it will be exactly perpendicular to the plane the parallel plane containing the conductor and the magnetic field. Of course, the current direction will be perpendicular to the direction of the magnetic field, but I'm saying the plane carrying the conductor and the magnetic field ro perpendicular direction रे force पड़िबो देखो एई पटे जदि जाउची वर्तमान एई कम्यूटेटर टा B1 ब्रश रे लागि छी B1 and B2 are fixed. The commutator टा पूरा जॉइंट हे जेची शाफ्ट संगरे कॉइल मूव करले शाफ्ट मूव करिवो से पूरा पूरी फिक्स्ड एवं ता संगे फिक्स्ड कम्यूटेटर हाफ स्प्लिट रिंग कम्यूटेटर विखंडित बळ भी फिक्स्ड ये आ संगे एपटे फिक्स्ड सेपटे फिक्स्ड किंतु बुलुचंती दुडा वर्तमान जते बेले करंटटा ए प्लस रु माइनस को जाउची वर्तमान ए पटे एमथि हेकी जाउची सो भितरे ए बी सी डी डायरेक्शन अछि तमे अप्लाई करो देखिबो तमे अप्लाई करो मु कोन अप्लाई करबी मु राइट हैंड अप्लाई करबी करंट डायरेक्शन टा को एमिति देखेबी and other एमिति देखेबी आउ एटा होचे नॉर्थ रु साउथ एमिति करंट से सो पुश करिवे तळु को ता माने एटा गोटे फोर्स पाइबो एपट पार्ट ता गोटे फोर्स पाइबो तळु को एट द सेम टाइम एपट पटटा ऊपर को उठिबो तमे निजे अप्लाई करो सो इट विल बी लाइक दिस एमिति जाउची बुलिया सिकरी एमिति जाउची सो करंट डायरेक्शन टा एमिति अछि so एपटे तळु को एपट लेंथ वेक्टर तळु को एटा ऊपर को so that it will get a torque and it will rotate but torque पाई गले से रोटेट करिवो एपटे सेपटे जेहेतु आमे पढिबा थीटाटा 0 डिग्री सो बीआईएल sin थीटाटा 0 आ ऊपर किछि फोर्स पड़ेनी केवल एटा जोटा अछि perpendicular to the field then only theta is 90 degree and then only BIL sin theta is equal to BIL. So it will get the maximum force and every time it is fixed because it kota higirachi so it's parallel so perpendicular poduthubo so the force is fixed. So jete bele aro patu ko etik asi gala 90 degree re etik asi gala sei samare tikke chadi hei gala current pasilani but inertia re padila the moment padila bartaman गोटे आउ गोटे पोजीशन देखैछि ना आउ 90 डिग्री परे पूरी फ्लैट करी देखैछि देखिबा पे सुविधा पाई वर्तमान लागि गलानी S1 कम्यूटेटर टा जोटा B1 रे लागितला जोटा B2 रे लागि गलानी आउ S2 कम्यूटेटर टा जोटा B2 रे लागितला वर्तमान B1 रे लागि गलानी फल रे कोन हबो ना करंट डायरेक्शन टाइम दियो एटा बैटरी ना फिक्स्ड करंट डायरेक्शन टा भितर गला पर कोन हला आकु जदी नेमिंग करछे ABCD ए CD पटटा एपट को चली आसिलानी तो वर्तमान जाउची DCBA ABCD जाउथिला because the A part was connected to S1 And here also the A part is connected to S1. But unfortunately, the S1 part has come to touch with B2. And the S2 part has now come to touch the B1. So bhitere jodi DCBA habo, current direction ta sei clockwise. It is clockwise. Kintu ame jo naming karthile ABCD so tan DCBA he gala. Jadio देखिले सेमती क्लॉकवाइज ये भी क्लॉकवाइज फल रे सेही एफएलआर सेही थापर रूल अप्लाई कले ये भी तळकु जीवो ऊपर को जीवो टॉर्कटा पाइबो सेम डायरेक्शन रे सो दैट इट विल बी रोटेटिंग सेम एंटी क्लॉकवाइज पुणी आउ 180 डिग्री पर्यंत सीधा पळेबो पुणी जेतळे वर्टिकल पोजीशन आसीबो इट विल लूज कांटेक्ट फॉर सम टाइम देन इनर्शिया विल टेक इट टू द अदर साइड सो अगेन S1 टा B1 को लागि जीवो S2 टा B2 लागि जीवो सो एम द कांस्टेंट करंट चलथिबो कांस्टेंट फोर्स ताको अप्लाई होतबो सेही जो the two sides of the coil which are perpendicular to the field but not which are parallel etar kichi padu nothiba doesn't matter eta padla se coil ta ko buleuthubo so chalila either this way or if you change the polarity of the battery but DC rahila tahale ethi anti clockwise bodole clockwise bulibo ethi ame sakal kar अधिवेशन को सांग करी पुणी ame आरंभ करिबा 7:05-10 bye bye और टिके शेष को टिके रखिकरी तमरो डाउट्स फाउट सब क्लियर कर